Okay, so I'm Alexis. I'm a lead system developer at Rudder, and I will talk about after Nicolas's talk. I will talk about a more detailed topic about Rudder after this general introduction, and it will be something around what happens on the managed system side in the agent, and most precisely about configuration file security audits. So I will start by giving you some context about why we ended up developing this kind of features. To just repeat rapidly what Rudder is about, it's a security posture automation tool. It works on Linux and Windows, and it's mostly built on a core, which is a configuration management tool. But we also provide other features on top of this configuration management core, like configuration audits, patch management, vulnerability management, and more specifically, and what we'll talk about today, security benchmark, which is the latest big feature we introduced. So what is it about? What we call security benchmarks are a set of hardening guidelines you probably have heard of. Probably the most popular are the CIS benchmarks. Who knows about the CIS benchmarks? At least a bit. Okay. CIS benchmarks are a list of configuration points that should improve the security of a system. They're provided for a lot of different operating systems and software. There are other hardening guidelines that people may use, especially from governments, but CIS has the quality of being quite independent. And companies and organizations in general have a growing need to apply some hardening policies for good or bad reasons, but it becomes a legal obligation for them. So that's something we saw for our customers. And the tools provided with these, usually provided with these guidelines, are mostly audit only, they I will give you more details just after, but sometimes looks like configuration management never happened in this world, and they do everything with ugly shell scripts, and yeah. So this is an actual excerpt to check a value in a file from CIS. So this is what CIS benchmark looks like. It's mostly a huge PDF for each operating system version, around 1,000 pages to give you an idea. And it contains a list of items to manage with 4 levels of numbering. So this is really fun to implement. And so you have an explanation, a description of how you can audit the configuration, and an explanation of how you can remediate this. So in this case, we have a value in login.diffs that should be higher than 7. Okay. So that's what it describes, and then we have some metadata about why is it important to set it correctly. So we can see we have really 2 different worlds here. We have the configuration management automation world, where we have a desired state, often nicely modeled with a DSL or specific data files. We apply it on our systems. Usually we get okay, not okay feedback. We expect it to be green basically every time. We have logs when it fails, but it's mostly for technical use. Whereas in the security audit world, if we have a look at the software used there, we mostly start from a set of acceptable states for the systems. So this is not a precise definition, but boundaries of what is acceptable or not. And then the tool will compare it to what's in the world and will provide a result, which is generally more granular, because it is always expected that some parts will not be compliant, contrary to automation configuration management, where we expect things to work. And in the audit world, things are not compliant, and we must live with it. And usually there is a scoring or system to give meaning to the result, to get an overview and not just the technical logs. Sometimes they include a remediation mode, but as I said, it's often like if configuration management hadn't existed and everything is just shell scripts that run directly. So the problem we had is that we have a configuration management tool. We want to do security auditing. What do? We could develop a separate tool for this, but that's not something we want to do. What would be ideal would be to find a way to include the audit needs in our tool. So what would we need in order to do that? We need to enrich our model to include the concept of acceptable state and not always a specific desired state. And we need to add some metadata to be able to compute scores. And we need, most importantly, better output from the system because we need to have precise information about the state of the system, even if it's not correct. And that's something configuration management tools are not always good at doing. So it gives something like this. We have a set of acceptable states, probably a desired state that we can enforce, and different modes. We could just audit, we could enforce everything, or we could have an hybrid mode where we enforce when it's not acceptable. And that's something that is actually useful in this context. That's what we actually want, and that's why we don't want to have two different tools. So in practice, how to achieve this? We already have kind of a focus on, as Nicolas has shown, on compliance, scoring, and visualization of the results. But that's something that only exists on basically on the interface side. On the local side of the managed systems, the agent is a very standard configuration management agent, and the current audit features were based on a dry run mode that doesn't provide much information. So the first kind of resource we decided to work on in this context are the configuration files, because they are one of the most common configuration points in these auditing guides. And so that was the first step we worked on. So we already had some tooling to edit files, but it was mostly regular expression based and not very powerful. And we, as most configuration management tools, try to push users to use templates to copy files and to avoid file editions because that's brittle and complex. So we didn't have the infrastructure to make these audits. So we had a look at what we could use off the shelf. And actually, we decided to use Augeas. It is now almost, it started almost 20 years ago. And it's a tool designed to allow editing a lot of configuration files, especially Linux configuration files, because there are a lot of different formats and editions. Automated editions are hard. It's probably mostly known because it was used in Puppet for file editions. It's probably seen as hard to use, and as file editions are less and less common, it's kind of not totally abandoned, but in, I would say, maintenance mode. Who has already used Augeas or has read Augeas scripts? Okay. So it's still the best option for automating complex file editions. The complexity actually matches the problem which is behind, and it's a hard problem. Editing any configuration file format is a hard problem, and Augeas is actually, I think, a very nice design in this field. And as we'll see, it's actually good for audits because of these design choices that were not specially made for audits, but that reveal themselves quite good. So for those who don't know, I will give you a very, very brief introduction to Augeas. The concept is that you will point it to a configuration file for which it knows the syntax. It will parse it in a tree structure that we can see here. So you have the path on the file system, and then you have the content of the file as a path in the tree. And you can see here is an fstab file with two entries. So we have the different properties, and you can also see we have the comments. So it preserves the formatting of the file. And it's a kind of an intermediate level of abstraction because it hides the syntax, but it does not try to replace to provide an abstraction of the logic of the configuration. It's just a representation, a textual representation, but nothing more. But it's already a lot, as you will see. So that's the first step. It parses the file, and then you can work on this tree structure. You can edit some parts, you can get the values, you can remove some parts of the file. So you can do any type of manipulation on the file. And then you can save to disk with a save command. So it can be used either as the script or interactively with a tool called Augtool. So that's the basics of how it works. And it knows a lot of Linux configuration file formats already. So that's the basics. Why is it good? It's based on what's called lenses, which are a concept of a programming language that describes bidirectional transformations. So here you can, that's a generic representation, but here you can imagine the file system on the left. So here you have the file on the file system, and Augeas will be able to read it and display it in another format, which is here our view. And there we can make any transformation we like we want to do on this representation. We can work on the file, on the tree, do whatever we want, and at the end we can decide to write it back, and it will preserve the syntax and just modify what has been changed here. So this gives this two-way vision that is great, because a lot of other tools are write only, especially in the configuration management domain. And here we have this visualization step that is great for audits. So we just plug my C. Okay. So yeah. So in Augeas, how are lenses used? Lenses are actually what describe a configuration file format. So you have a lens for each file format you can edit, and they describe the transformations you can do. And so you can push changes to the systems. So, okay, we have Augeas as a good basis that can read content from file in a usable form, and especially consistent form, because we can work on any file type with the same interface, and we can write it back. So we have both, we can both get the file structure and write it back. But it's not enough, so we need to extend Augeas for our needs, especially our audit needs. We have basically three things we need to do. We need to have assertions, because Augeas only edits things, but we need also to check for some properties on the values. We want the ability to do a pure audit mode, and also we want to have more detailed output, because Augeas doesn't really say much about what it does. But this, instead of modifying Augeas, which would be hard, and plus we don't really want it to do it, we decided to create a wrapper. So we actually use Rust for the system code in Rudder, and there was already a beginning of a library for Augeas, so we took it and improved it so that we get a Rust-based interface to Augeas. So okay, now we have the library, we can start extending it. The first extension we made is a new keyword in the language to have assertions. I will go over it quickly. And we also added another CLI tool called Rocktool, which is exactly Augtool, but with our extension. So what is this check keyword? The idea is that a lot of security benchmarks describe some constraints on the values, but not always a precise expected value, but this value, like the example I gave, should be above 7. And that's something we can describe with our check keyword. But we also added regular expression matching. We also have numerical comparisons, including sizes, path comparisons. We also have features for checking password strength without never outputting the actual password value, but just estimating it without with two possible mechanisms. So one is a very standard minimum count of character by class, and the second is actually a nice system of scoring the strength of a password based on a dictionary and an estimation of the entropy. Okay, so these were the individual assertions we can make, but there are other types of assertions which are actually very important in the security audits context. The first one is basically the ability to iterate over values with the simple assertions. For example, if you have a lot of IPs in a file and you want to ensure they are all in a specific subnet, then you can use this syntax with the star, and it will iterate on all the values that match this selector. So yeah, basically a path in Augeas can include, you can have a complete path, but you can also have a kind of a globbing system where you can match several entries. And in this case, if it matches several entries, it will check the requirement for each entry that matches the selector. And we have another type of assertions which is actually needed, and it's the ability to make assertions on lists directly. In a lot of contexts, you can have configuration files containing a list, and you may want this list to be a subset of another list, or to be equal to a list, but regardless of the order. So with this, this is actually two equal signs. That's because of the ligatures, but two equal signs means any order but must match the list, and with three equal signs, it means it must be this exact list in this order. So this allows quite advanced assertions, and that's something that's actually needed for CIS compliance. Okay, so this was the extension of the language. We still have two things missing. The first one is the ability to make audit-only scripts, because Augeas is made as an edition tool. So what we did is we actually have an interpreter that stands in front of the Augeas interpreter, and that intercepts everything and checks the commands, and for example prevents the save command in audit context because we don't want to write anything on the file system. It also handles our check commands extension. We also have modes for fail fast versus collect as many errors as possible, depending on the mode we're working on. I won't go into much details. It's mostly code related, but yes, that's what allows us to plug this system into the existing Rudder abstractions and everything. So we have the language extension, we have the interpreter, and now we need a better output, because Augeas by default does not display anything. It's made as an edition tool. So whenever possible, and especially in the case of the check, the assertion keyword, we try to use this kind of messages. It's made possible by the spans feature of Augeas, and we use kind of compiler-like error messages that point to the source and the exact point in the source that is not compliant with the assertion. And for the rest of the editions, we use file diffs quite simply using the preview feature of Augeas. So that means when you edit a file in the tree in memory, you can query Augeas to ask it what would be the output if you asked it to write it to the disk now. And so you can make diffs without writing anything on the disk. And that's what we use for the output. Okay, so now we have everything we need. Let's integrate it into Rudder. So the first part the users will see is the configuration side. So Rudder has an interface that allows to configure everything. The interface is actually another representation of the same structure as a YAML. So this is how it is used. A few differences with the plain Augeas is that we have this if script mechanism that is run first, and if the script returns true, it will run the actual script. This is needed because it's sometimes hard to make idempotent Augeas scripts. So this allows to make it like manually with a check step and then addition. And it works on one file. As you can see, you pass the path of the file that allows to only load this file, because by default Augeas will load the whole configuration of the system. That's not something we want. Okay, so now we have rudder integration, and once you have executed it, like Nicolas showed, you get feedback in the web interface. And in this case, for example, I have a file edition, and you can see that the complete diff is returned to the web interface. And it's also true for audits. So if we audited the file with the same configuration, it would show the exact same output. Or with the error message, the compiler-like error message we provided. So in conclusion, I really think we can still improve configuration management, and adding these auditing capabilities actually forces us to focus on the measuring, observing side, which is actually part of good automation, I think. It also moves the focus a bit of the desired state, because the desired state is never actually the reality, and it forces us to learn to live with some various levels of correctness for our program, for our policies, and actually manage the differences between the expected state and the reality, and not just have an error and don't know what to do about it. So this bi-directional architecture is really nice compared to the push mode that is often the default in configuration management. We do this as an incremental change, so we add new resource types and more information in the output for resource type over time. So this is not a big bang in any way. And final word, Augeas is actually nice, even if it may seem a bit complex at first. When you dig a bit into it, the design is really nice and actually solved a problem that it was not supposed to solve because of its good design. So thank you. Do you have questions? Maybe?
Why did you choose to make a wrapper around Augeas instead of offering to add the corresponding mode to the
The first reason is that we prefer to write Rust versus C. That's the basic reason, because we needed to make the bridge between Rust and C, and we prefer to make the glue in Rust than in C, basically. Yeah.
So most of the assertions seem to be on individual fields. Can you give me kind of cross-field constraint? Like X is greater than Y?
For now, no. And there is no logic. There is no if or thing like that. Yeah.
Did you have any concerns about the future maintainership of Augeas?
Yes, I didn't have.
It's hardly been updated the last few years.
Yes. It's more or less abandoned. What we plan to do is to, especially on a security point of view, is to sandbox it more, so that it's not liability in terms of security. And we actually currently provide the fork of Augeas because we have some patches that we applied, and so yes. So we actually kind of maintain a part of a.
That's it. I mean, a few years ago, I remember it was looking for a maintainer, and nobody came forward.
Yeah.
But it's not something you're sort of taking on.
We're taking on the parts we need for now. Yeah. Thank you.